Now, when you consider the process of a database design, there are two distinct phases, and that's logical database design and then the actual physical database design. And so in this video, let's talk about the logical database design. The logical database design is really all about logic. It is where we're going to talk to the customer, listen to what they do, how their business works, what they're needing the database to accomplish for them, and we're trying to mesh the logic of the customer as they understand the data challenges and the data needs with the logic of the database designer, and us bringing our expertise in building a physical database to mesh and meet perfectly with the needs of the customer as far as how they need to store the data and what they need it to do. So our job is going to be here is to model a database that will collect, manage, and deliver the data required by the customer. Now, you always know you're sliding off track when in a meeting, and I've heard this quite a bit in my career, they say, whoa, you're talking geek now. You're talking, I can't understand what you're saying. That is the very purpose of logical database design. I have got to somehow work with that client, and I've got to listen to what they need. Then I've got to show them what I'm going to build, how I'm going to design it, and make sure that it makes sense to both of us and it's going to deliver exactly what they need. Now, at this point in the design, we're not vendor software specific. This is not about SQL Server or Oracle or MySQL or anything else. This is just generic database design. Put data in tables, relate it this way. You need to see this, you need to do that, you need to check that over there, that sort of thing. Now, the logical design itself involves two major steps. The first one is gathering the business requirements from your client or your customer, and then converting those requirements into a model that makes sense to you on how it's going to work and makes sense to them on what it's going to look like and how their particular business is going to fit in. When you do a logical design, the typical deliverables that you will see at the end of the process is one or more entity relationship diagrams, or ERDs. Now, these provide a visual representation of the various categories of data and how they relate. Now, this is where you kind of mesh together your understanding of what the customer told you, and they can look at the graphs and the visuals of this and say, oh, no, wait a minute, no. Accounting never gets involved right here. Accounting shouldn't even be connected. Those kinds of questions will pop up on those diagrams, and you can settle those questions before you actually begin to build the physical database. Then there will be some business process diagrams to illustrate how data moves within an organization. Can't tell you how many times I've interviewed within an organization, and in the process of putting together these business process diagrams, find out that sees the data moving within the organization totally different from marketing, and marketing sees it totally different from accounting, and everybody sees it different from executive. And there's been some pretty interesting meetings in some of these companies as these people realize they have not all been on the same page since day one. Now, it also illustrates the activities of individuals in the organization, because usually you have one or two major players who are either doing the lion's share of the cost-effective work, or they're kind of directing everything, or everything kind of naturally hubs at their desk. And by being able to illustrate the activities of individuals, you can also get to a finished product on, number one, what this thing's going to look like, how everything relates, how it's going to work, how the data is going to flow, and then you can get to the business of actually designing it. And then, of course, you need user feedback. We want to talk to users, let them look at this, let them ask questions. I can't tell you how many times we've solved a lot of problems up front because we let the end users look at it and say, you know what would really be nice here? And a great question to always ask these people is, what's the one thing that you've always needed but you've never had access to with your software applications? And a lot of times they'll say simple little things, and you can just change their world with it. So anyway, logical database design, we're doing a lot of give and take, a lot of talking. We're going to translate what they need, how their business works, into a logical design that we're going to implement as a physical database. In an earlier video, we talked about the logical database design, kind of the meeting of the minds, if you will, between the client or the business and how they operate and what they need, and the designer, database designer, who's trying to get that organized in such a way that they can model the relationships and the data flow and so forth. Once all that has happened, we're ready then to actually go out and build that database or construct a physical database off that logical design. So this is the actual design of the database that was described in the logical design process and in those ERD diagrams and deliverables that we talked about in the video entitled Logical Database Design. So what we're doing here is we're converting the required functionality that was described to us by the customer into a working relational database. Now, this can be a bit challenging sometimes, and a lot of times it can kind of become sort of an iterative process because you'll bump into a challenge, you'll see things a little more clearly when you begin to actually implement them, and you can go back and say, hey, I've got an idea here, will this work for you guys? Now, keep in mind, the logical design was not based on any particular software. The physical database design is going to need to be based on whatever your chosen relational database management system product is. In the case of this particular course, that is Microsoft SQL Server 2012. Because while all relational database management products do roughly the same thing, they implement a lot of things differently. And so the more you understand about your particular chosen database management system, obviously, the better the physical design is going to come out. Now, the typical deliverables that you're going to generate on a physical database design, first of all, you're going to create your tables, and these are going to be based on the entities and the attributes that were identified in the logical design. Then, you're going to implement the columns and data types. You're going to identify them, you're going to implement them in the tables. And of course, the columns are going to be the individual pieces of information that need to be stored in each table where they're interrelated. And so you'll implement those. You'll also choose proper data types. Then you'll define your constraints on your tables, your primary foreign keys, your unique keys, your check constraints, those sorts of things. So we want to build our tables, start to construct the relationships, and again, just kind of start to flesh out a physical design that matches the requirements and the functionalities laid out in that logical design. Next up, we'll probably create some server model diagrams that will detail tables, columns, relationships, those sorts of things. And again, this can go back to the client, and you can explain to them a little bit about how exactly you're going to build these things. And a lot of times their IT people can get involved here and help you with server loads and that sort of thing. Then you will create a database design documentation. Everybody can read over this. Everybody can agree to this. This kind of becomes the ultimate requirements document that everybody signs off on. And then, of course, we're going to solicit some user feedback again, because users will surprise you sometimes at how quickly they grasp this stuff, and it's somewhat intimidating to realize that it's not exactly the rocket science that we had hoped we were impressing everyone with. But a lot of times the accountants, the engineers, especially those detailed type folks, can really grasp this stuff and understand some of these relationships. And I've had them suggest things that really were great ideas. Of course, my response is, yeah, well, I'll take a look at trying to work that in. And privately, I'm thinking, wow, that's a great idea. I'll use that. So anyway, physical database design, simply put, we're going to take our logical design, which is our customer needs, requirements, the actual data flow of the company. We're going to work that into a physical database with tables, constraints, relationships, and all that, and produce a database that will provide them the service, the management, and the storage that they need. Collation is a topic that will probably show up on this exam in one form or another, and so let's talk about understanding collation in this video. And to start off with the direct question, what exactly is collation? Collation refers to the sorting rules, the case, the accent sensitivity, those kinds of properties for your data. In other words, it's how the SQL Server machine knows how to sort certain characters, work with case sensitivity, accents for different languages, and that sort of thing. Good example. The collation choice affects some of the characters that can be represented for certain data types, such as the char or the varchar characters. And so keep in mind that collation can be set at 4 levels. Now, in a design environment, you may be put in a position of designing a database in a very large enterprise organization. You probably see this on the exam, and you've got to make your design fit into their world. Now, one of the things you want to know is what collation are they set on their databases, because they need to match. Now, most of the time in our world, we just take the default collation on SQL Server on every installation and everybody's fine, okay? But keep in mind there's a lot of different collations we can set, and they will make minor differences in how SQL Server treats our data. Now, collation can be set at 4 levels. The first level is the server level collation, and this is set during the SQL Server installation. Now, we usually just kind of go past that and don't change it, and that's probably a good idea. But just understand the implications that when you take that server level collation, it becomes the default collation for the system database and all user databases that you create on that SQL Server. Database level collations can be set when the database is created. Of course, again, we normally don't do that, but we can use the collate clause of the create or alter database statement to set it to a different one if we would like. And if we don't mention collation, or if we don't change it, the server level collation is the default for all of our new databases. Now, the column level collations can be set when the tables are created, or they can be altered. We can alter the table using the collate clause. Again, the database collation is the default. Now, obviously, the farther you go into the detail level here, the trickier it gets dealing with these collations. But the column level collation allows you to apply a different collation to a particular column in a table than to everything else in the database. It can be tricky, but in multinational corporations, sometimes this becomes a real need. Expression level collation is the ultimate in control. You can set when a statement is run. This is set when a statement is run by using the collate clause. Here's an example of that. We're going to select the name from the customer table, order by name, collate, Latin 1 General CSAI. And so we're telling it to select this data from this customer table by using this particular collation. All right? Now, collations can really become tricky. And let me just give you a note. SQL Server supports storing objects that have different collations in a single database. Watch for that on the exam. They may word it to you in a way that it sounds like you're really doing, some serious nuclear science. But yes, simple answer, I can support storing objects with different collations within my single database, not a problem. Here's where the problem is. Transact SQL statement results may vary when you run against different databases with different collation settings. In other words, the same query run against the same data on different machines, or very similar data on different machines within the same company, could give you fairly different results if the two different SQL servers have different collation settings. Okay? Again, the collation is telling it how to sort things, how to deal with sensitivity, and that sort of thing. So make sure you understand what collation is. If this is a totally new topic to you, go out into books online and read about it just a little bit. Otherwise, just understand collation can be changed. In an ideal world, it's the same on every machine and every database and every table and so forth, but it is possible to run different collations when you just have to. Now let's turn our attention to linked servers. Now, linked servers is a functionality that you need to be aware of from a design standpoint, because in particular situations it can be a lifesaver. So let's start off with a simple question as always. What is a linked server? A linked server is a configuration that we're going to do when we have more than one SQL Server database server out there. Now, this is a configuration that allows the SQL Server database engine to execute commands on an OLEDB, or an object linking embedded database data source, on other servers. And this could even be on the same server in a different database. Now, a linked server allows us to reach outside the instance of the SQL Server where the command is actually executed. All right, now let's talk a little bit more about this. What can I do with a linked server? Well, I can execute what's called a distributed query, a query that's distributed across multiple servers, across great distances, across a network. However I want to do that, to execute against other OLEDB data sources. Now, I don't want to go too deep and confuse you here, but an OLEDB data source can be other databases, for example, an Oracle database. It can be other data sources that aren't necessarily databases. It could be a spreadsheet. It can be a lot of things. Okay, so if it's OLEDB and if exposed that way and we can connect to it that way, we can consume that data in a distributed format. Now, what are the advantages of doing this? The advantages are that we can access data from outside a SQL Server meaning we can reach into a SQL Server database or any LADB data source from any other SQL Server. Now, we can issue distributed queries, updates, commands, and transactions on, watch this word here, heterogeneous data sources across the enterprise, meaning they don't all have to be SQL Server. We can connect to other database products, we can connect to other LADB data sources, and we can consume that data. We just have to use the four-part naming in the query. All right, and that is, we put the linked server name, and in this instance I put database to make it a little easier to understand, but catalog, or the source of the data, that foreign data, the schema, and then the object name. Now, if we were trying to do a distributed query to another SQL server, we would create the linked server, and I'll talk about how to do that in just a moment. And then, from the local SQL server that I'm working on, I would write a query, and I'd say select everything from, and I would put linked server name, the name of the server I'm linked to, the remote server, the database on that server that I want to connect to, the schema that I want to reach into, and then the object name or the table name that I want to query from, or that I want to touch. Okay, so that's the four-part naming, and once I have linked that server, then that is a permanent linkage, and from that point on, all I need to do to retrieve or manipulate data on that linked server is use that four-part name. Now, this gives me the ability to address various data sources very, very similarly. Now, how do I go about doing something like this? Well, you can do it in the SQL Server Management Studio, or you can run the stored procedure. This is a stored procedure that comes pre-programmed with SQL Server when you install it, the add linked server transact SQL command. And I'm not going to go into how to set one of these up. You can go read about that and play with it. But from a design standpoint is how I want you to think about these linked servers. This allows data to be segregated into different databases. Now, from time to time, you're going to get into a database design situation where you've got databases that the data needs to be segregated physically. Number one, for storage reasons. Maybe the storage is just too large. You can't put them all in one single database. Number two, there could be legal reasons. Your company is in one of these legally regulated organizations where you have to have both of these pieces of data, but they can't be mixed and they can't be touching or intermingled. And then there could be maintenance reasons. I simply want to separate these for maintenance purposes, for safety purposes, for whatever reason, but this makes it very easy to separate data and still access it by using one single query or one single reporting tool. So linked servers are a fabulous idea. We'll talk about these as compared to other things like Open Row Set a little bit later on in the course. Just look for a video entitled Linked Servers or Open Row Set and you'll see what I'm talking about. But linked servers are a great tool. Just keep in mind they establish that permanent connection, and from that point on we can just use four-part naming on our queries to connect to objects and query and manipulate objects on that remote server. In this video, I want to address the topic of nulls, and we're going to come at it from the standpoint of understanding nulls. Now, for some of you, this might be Database 101, but I want to make sure everybody's on the same page here because this will come up somewhere, some way in your database design exam. Now, there are two things you should make sure that you understand about a null value. The first thing you need to understand is what null means. Null means an unknown value. When you see null in a database, it simply means something belongs here, something will be here later at some point in the future. However, right now, we don't know what that value is. Doesn't mean this particular row or this entity doesn't have this value. It's just that we don't know what it is to include it in the row right now or in this field. Now, what does null not mean? Now, keep in mind, we've all, if you've been around databases for a few years, going back to the early days of things like DBase and Access, we have been miseducated, if you will. We've been taught the wrong things, and we've got to get over it, all right? But null does not mean blank. Null doesn't mean blank, no data. Null doesn't mean no. It doesn't mean false. It doesn't mean zero, any of that sort of thing. Null means there's an unknown value being stored here right now. Now, what's the big deal with this? Well, let's talk about it for a second. Let's put it in these terms: religion, politics, and null. Okay? If you want to get somebody to disagree with you really quickly, start talking about religion or politics. And if you want a database designer or an administrator or a developer to disagree with you really quickly, start spouting your views on null. Many database designers disagree over the use of null. You can go out to Google, just type, should I use nulls or not in my database? And you can find fights all over the internet about this. Keep in mind, though, null is part of your database design options. Go find, 3 or 4 database nerds, ask them about nulls, and you'll get 2 or 3 different answers, and some of them will be pretty vociferous in their opinion. Okay, vociferous is a sort of technical term for all in your face, talking loud, shaking all over, turning red, that sort of thing. Now, what's wrong with allowing a null in the columns of your table? Well, nulls require special handling every time they are touched. Now, that statement's not exactly true. I'll touch on that a little bit more in a video entitled ANSI nulls. But in the not too distant future, that statement is going to become exactly true in SQL Server 2012. That's a little nerd teaser for ANSI nulls video, okay? Now, why would we want to build a database so that we can store unknown data? It's much more efficient to store unknown data out there in the atmosphere, right? And then once we know what the data is, then we'll start to store that stuff in a database. Nobody puts empty boxes in their closet to store unknown things, right? We just wait till we get the things, we know what they are, then we put them in boxes. Also, nulls breaks the two-value logic standard. The two-value logic standard is yes, no, true, false, on, off, 0, 1. The basic computer operational method. Null turns it into yes, no, unknown, 0, 1, unknown. And this creates a problem for processing. Now, what are my design options when it comes to null? Well, you can allow tables to have columns that allow null values. We see these every day. You see them all the time. The general rule amongst most people is that a few nulls are okay. They're a part of life. There's not a lot you can do about them, and they're going to be there. The next thing is that instead of allowing null values, just normalize any of those columns that you want to have nullable and put them into related tables so that they only store data for the rows that have data, and only when that data is known, and you never see null out there anywhere. Now, that sounds like an easy solution until you realize on a large database it adds an extra 100 or 200 tables to your database, and that becomes a problem, especially on reporting. Then there's another trick that we did back in the old DBase days, and that was we added a known value that indicates the actual value is unknown, like a date of 99, 99, 99, 99. That's okay, but most designers just consider it a bad idea. You're storing data you don't need. The meaning may not be apparent under certain conditions, all those sorts of things, okay? So here's the exam. What you need to know for the exam with nulls: a few nullable columns are okay in a table. Too many nullable columns create incoherent or incomplete data. The deal is, though, you decide how many is too many. And on the exam, some examples will be obvious, okay? So you should be able to pick these out pretty easily. If you see a table, most of the columns are null, that's a problem, all right? In the real world, you have to deal with your other designers, people around you, kind of see how they feel. A few nulls are okay, but again, don't overdo it or it starts to become problematic, especially down the road. We'll talk about that in a video entitled ANSI nulls. Now let's turn our attention to ANSI nulls. Now, I talked about nulls in general in a video entitled Understanding Nulls. So if you haven't seen that one, go back and watch it and then come back here. It'll probably help you understand the setup for this a little bit better. Now let's start off with the basic question. What is ANSI, A-N-S-I? Well, if you go all the way back to the beginning of the course here, we talked about a little history on SQL Server. We talked about those standards, right? And ANSI, the American National Standards Institute, are the good people who gave us those standards. This is the very same organization that manages, the SQL 89 standard, the SQL 99, the SQL 2003 standard, the things that we use to make sure that all the SQL languages across all the platforms have the same general aspects in common and will intermingle and work across platforms. Now, part of that very same standard is how nulls are handled by the databases. Let's do a little example here. What's wrong with this particular query? I want to select the last name, the column last name, from employees. So I have a table employees that has a column named last name. So I'm going to select last name from the employees table where phone equals null. Now, how can I check for equality on an unknown value? And let me get a little philosophical here, okay? If I'm saying where phone equals null, that means where the phone field equals an unknown value. I have 2 styrofoam cups in my hand. Picture this, okay? Close your eyes. Focus. Picture this. 2 styrofoam cups, 1 in each hand. I have unknown values in both of these cups. How can I ever know when these cups' values equal each other? Of course, the simple answer is I can't. Now, you can say, wait a minute, Mark, you're really reaching pretty far here because it's pretty obvious that all we're looking for in this query is anywhere the phone has a null value there. And you would be exactly right. But to query it that way, what we really should be saying is we want to select the last name from employees where phone is null, where the phone value is unknown, where null has been entered there. All right? Now, what's the big deal here? I know it looks like I'm reaching for straws here to make SQL appear to be even more complex than it already seems to be. But that's not exactly the case. Here's the big deal. SQL Server can handle nulls either way. We can use a command in Transact SQL called set ANSI nulls on or off. And we can also set ANSI defaults. There's other things that will affect how ANSI nulls is set, but the bottom line is we can turn them on or off. Now, the default on SQL Server 2012 is that ANSI nulls is set to off. Now what that means is we don't abide by all those stodgy rules that ANSI has set up on nulls. Meaning, if I do the query and in the where clause I put where the phone is equal to null, it will return all the rows where phone contains the word null. So, in effect, I'm kind of saying, look, let's don't get too philosophical here. All the dude wants to know is there a null value in the phone column? Yes, let's return it to him. Okay, no big deal, right? But if I set the ANSI nulls to on, no rows would be returned because it starts to really adhere to logic and it says, wait a minute, you can't equal an unknown value. How would you ever know? It's unknown. So, here's all you need to understand. Right now, you can get away with it. We've been trained this way with Access and DBase and all these other old tools. However, future versions of SQL Server, Microsoft's already warning us, will default to ANSI nulls being set to on, which means our little phone equals null would not return any rows. Not only that, when you set the option to off to try to get it back to where phone will equal null, it will generate an error. Now, once this happens to SQL Server, nulls really will always require special handling, and so you really want to be judicious in your use of ANSI nulls, okay, or how you use nulls, because ANSI is really going to become the standard for SQL Server, and you can't turn it back and forth. Now, from a design standpoint, you want to, first of all, develop accordingly for the future, and you need to know what the ANSI null setting on your particular database is going to be, because let's go back to linked servers and all that other stuff I was talking about, and we'll talk about open row set a little bit later. When I'm trying to link out to another database and say it's Oracle, what happens if my database ANSI nulls are off and on Oracle ANSI nulls are on? It can create some problems with the data that I get back, all right? So keep this in mind. You always want to know what the settings are for ANSI nulls. Most of the time, for most of us, on the SQL Server platform, it's defaulting to off and everything's okay. Just make sure you know this. Watch for this on that design exam and make sure that if they turn ANSI nulls on, or if they ask you that ANSI nulls need to be on, then these type queries aren't going to work. Or if you get a scenario where queries like this aren't working on the exam in a design, it could be that ANSI nulls have been turned on. Okay, so go through this again a time or two if it's confusing. I hope I've helped here, but that's a quick look at ANSI nulls. one aspect of database design that you need to be concerned about, and you will probably see questions on the exam about this topic, is how are you going to handle database growth? Because databases all have one thing in common, and when I say all, I mean probably 99.999% of them, and that is they grow. They simply collect more and more data, they get larger and larger, and the data file size gets set when you create the database. Now, you can use the create database statement, and one really neat trick that I can give you, or tip, for preparing for this exam, are to take the commands like create database, create table, create index, all those things, go out into books online and read those things. Especially look at the options that are available for you when you're working with those commands. You can learn a lot about what can be done, about different nuances you can invoke for database design type situations. But what I want to do is let's jump out into the SQL Server Management Studio, and notice that I've just got a connection to my SQL Server here. This is pretty straightforward. I'm just going to right click. I'm going to left click first on databases. Always left click first, highlight it like you see here. Then I will right click and tell it I want to do a new database. Left click on that. Now notice it's asking for a name up here. I can put whatever I want. But what we're concerned about here is the name of my database. Okay, I could put a name in here to name the database, and notice the initial size here is 3 megabytes. I mentioned file groups earlier. There's a primary. If I had new file groups out here, I'd see a drop down, a way to assign it to a different file group. But with this, this is going to be 3 megabytes. That's probably too small, right? So I could easily set this to, say, 300 megabytes. And then notice on auto growth, it's going to grow by 1 megabyte every time it needs to grow. Or I could click the ellipsis out here and tell it percents or in megabytes. And notice I can change this. And then I can set a maximum file size. Or, and hang on to this, we're going to talk about this in just a few seconds here, I can turn off auto growth altogether. All right? So that's how you would do it in the interface. So let's come back here and talk just a minute now. There are two options for dealing with future growth in your database. Number one is you can just set it to unlimited and just let it go. And then there is a file growth option where you can set how often it grows. Now, under unlimited, if I choose an unlimited file size, the data files are going to grow until the disk is full or until the data size reaches the maximum size of 16 terabytes. And we'll just kind of leave that alone right there for now. Now, on the file growth, I can tell it how much to grow every time that it needs to. And with the file growth, I can tell it to add space to the file every time new space is required. Now, watch that sentence right there. We're going to come back and talk about that in just a minute. So every time new space is required, it will automatically add space. And the growth increment will tell it how much space to add every time it needs more space. And so if I tell it the growth increment is 10 megabytes, then every time the database needs more space, it's automatically going to add 10 megabytes to it. So we obviously want to watch that. We don't want it adding space, like 6 times a day. So we might want to make sure that when we add space, add 50 megabytes to it, right? Whatever. Now we can increment in megabytes, kilobytes, gigabytes, terabytes, or by percent. And a lot of people like percent that use file growth because as the database gets larger, we can naturally assume that it's going to be growing faster. So we can use a percent, and 10% of 100 megabytes is going to be 10 megabytes. 10% of a terabyte, right, is going to be 100 megabytes. And so the percentage keeps the growth actually growing. The default growth increment, if you don't mess with it, you saw it just a few minutes ago, is 1 megabyte. Now, here's what you need to know about database growth. Automatic file growth happens when it's needed, not when it's convenient for you, not during non-peak times, but when it's needed. And keep in mind, when auto growth happens, it affects performance. It applies a schema lock on your database, on all the tables. They're going to lock up for just a moment. Users aren't going to be able to access it for just a few seconds. But if you're in your peak time, this could be pretty dramatic for you. So you can't control when it happens. The best practice, the best thing you can do here is to estimate your database size, set it at creation, and keep a check on it. So if you think this thing is going to turn into a 600 megabyte database, Set it at 600 megabytes when you create it, okay? Then you can turn off auto growth, and you can use the alter database command to add space as you need it. Now you're in control. You can add space, you know, during nights, weekends, non-peak times, this sort of thing, and you're not going to get into trouble doing this. And notice I've just got you a quick little example there for altering the database. This is the T-SQL command because I've demonstrated the little Management Studio way to do it, the graphical user interface way, just a little earlier in this video. But notice, just alter database, put the name of your database, modify file, and set the name of the file. If you remember, we could put the name back there in the graphical user interface, and just set the size to what you want it to be when it's been extended. Okay, so maybe this was a 10 megabyte file before. So anyway, that's how to handle database growth. Watch for these questions on the exam. Make sure it makes sense to you. Couple of ways to go, but the main thing, you do not want this thing auto growing on you in the middle of your day 2 or 3 times, because it is going to create some issues for users. One question you may see addressed on this design exam has to do with the topic of linked servers or open row set. Now, I've already talked about linked servers, and in this video I'm going to talk about open row set at the same time that I compare it to linked servers. Okay, well, here's the deal. In a perfect world, all of the data is in the same database. It's all clean, it's all happy, there's no issues, right? But also in a perfect world, politicians do more than they promise, and your actual mileage does not vary, right? So obviously we're not in a perfect world. And here's what's going to happen in your world. Your data is going to be out there in multiple databases and multiple servers in multiple locations, right? And distributed queries are going to be the answer to reaching onto all of these different servers sometimes and grabbing data that you need, especially for reporting, but a lot of times for inventory control, who knows what, okay? And sometimes this data ends up out there just as kind of an evolutionary result of how the business grew and how the business developed. Other times it's legal issues or some sort of, you know, government requirements, whatever. And so you're going to have data out there in a bunch of places. And so the question becomes, which is the best way to connect to this and run distributed queries? Well, let's talk about the 2 options. You can use linked servers, which I've already talked about. If you haven't seen that video, go take a look at it. It's entitled Linked Servers. And then there is a function that's a command in T-SQL called Open Row Set. And you should understand the difference between the 2 options because it could come into play on a question or 2. Now, with linked servers, we've already talked about it. We're going to configure a linked server by establishing a programmatic relationship between the servers that are linked, and now they just kind of recognize each other. And I can use 4-part naming, and by putting that 4-part naming in there, you'll notice I'm going to put the name of the linked server, the database that I'm trying to reach into, the schema, and the object name. This would be the table name usually, and I can reach into that remote server and just pull data. Now, since I've set up this linked server situation, when I just mention linked server here, it checks to see the server name, it sees that it's linked, and it just reaches out there and grabs it, okay? Because I've already satisfied security. However, most administrators are really concerned about the security implications here, because if I compromise one of your servers and you have linked servers up everywhere, then I just compromised every one of your servers. And so for that reason, they kind of like the idea of isolating everything. However, if you isolate everything and you don't have linked servers like that, how do you get the data on those other servers? Well, here's the general rule. You should use a linked server when frequent distributed queries are required and you're relatively comfortable with your security setup. Now, let's talk about open row set. This is a transact SQL function. This allows you to write a query and just pass the information, and you're passing connection information, destination information, and all that as part of the query. And this gives you a one-time ad hoc method of connecting to a remote data source and consuming that data. It is a every time you run the query kind of a linked server kind of a thing, okay? It does not set up any kind of permanent connection, and if anybody compromises your SQL server, they then won't know those other servers are out there, or there's not a linked server set up, they can't just dance right over to it. Now, by default, SQL Server does not allow ad hoc distributed queries. This is another security thing. So if you want to use Open Row Set, the configuration property for ad hoc distributed queries has to be set first. And I just want to show you a little simple example of how you would set that. You would use the store procedure, the system store procedure SP configure, and notice you would tell it to show advanced options, and then tell it 1, then reconfigure, and then you would call it again. You would pass it ad hoc distributed queries. That's the property you want to change. Set it to 1, hit reconfigure, and you would be ready to go. Now, notice I didn't show you how to do Open Row Set. I didn't step through how to do link servers. Go read about each one of these in Books Online. This could come up as a design issue. Are you going to use those remote servers? Are you going to do a link server to them? Or are you just going to Open Row Set when you need it? Open Row Set is obviously not nearly as convenient as a link server, but it does expose you to a few less security concerns. So that's the main difference between link servers and Open Row Set. It's just two different ways to get to the same data. Now let's talk about CPU affinity. This is a term and a functionality that you may well see on the exam, and it gets a little complex, but I just want to give you enough information here to get you acquainted with it and to help you understand how to deal with it on the exam. And then I'm going to strongly suggest that you go out to Books Online and do a little bit of reading on CPU affinity. Okay? Now, the enterprise SQL Server implementations out there in the real world usually will involve multiple SQL Server instances on one server because they're trying to cut down on hardware expense, and you'll also have, as a result, multiple CPUs on that same server. Now, multiple CPUs are better, right? 8's better than 4. 16's better than 8. The more CPUs, the faster, the better, the happier everything is. Not necessarily. What happens, SQL Server can use multiple CPUs to execute queries. However, if you'll stop to think about this, to use multiple CPUs, that means you have to keep up with which threads are running where on which CPU. And a lot of times, it's very possible for SQL to spend more time trying to do housekeeping and stay on the right thread and switch back and forth correctly than it does if it could just run the query on one CPU, kind of like the old tortoise and hare story, right? Just keep moving steadily. That's better than these quick little bursts and stops. And so you'll a lot of times spend more time switch processing between CPUs than you could just do if you just ran the operation on a single CPU. So the CPU affinity mask option can help with this problem. It will allow you to assign a SQL Server instance to a particular CPU or a particular processor. Good example. I have 4 CPUs on the server, and my first or my default instance is going to run on 2 processors. So I'm going to use CPU affinity, the CPU affinity mask option, to assign those first 2 CPUs to that default instance. Then the second instance is going to run on the next 2 processors. Again, I'll use the mask option to assign that. Now the first one always uses those 2 processors. The second one always uses the last 2 processors. And we don't get into this, really bizarre multiple processor switching mess that goes on that starts to kind of slow everything down. Now there's another thing to watch for here. The CPU affinity mask option will be removed in a future version of SQL Server. So while you may need to answer it on the exam and know what it is, and again, I strongly recommend that you go out, read in Books Online about the CPU affinity mask before you go take the exam so that you can kind of see all the little nuances. But this is going to come out in the future version of SQL Server, so they're saying don't program this into anything if you're doing that stuff. Don't count on this because in the future you're going to use the alter server configuration command instead. And you will see that in Books Online when you go out there and look, and you can read about that as well. But for now, what I want you to understand for the exam, you can control which processors in a server your different SQL Server instances use. And you want to do that because when you have too many processors, it can actually slow your processing down when SQL Server starts working too hard to switch back and forth. Okay? So just remember, when you got a lot of processors and it still appears to be running slow, you may want to go in and use the CPU affinity mask option to assign certain processors to that particular instance on that SQL Server. Memory allocation is a topic that I seldom even hear fairly experienced database administrators talk about. Now, part of the reason for that is, no doubt, that SQL Server automatically manages memory allocation by default, and so everybody kind of assumes that it's taken care of it. Now, what happens really is SQL Server attempts to provide itself with the maximum amount of memory that it needs to handle the workload that it's under efficiently. And so all of this is workload based. As SQL Server's workload goes up, it tries to go out and grab some more memory. Now, it has to make sure, obviously, that it leaves the OS, the operating system, with enough memory to avoid paging out to a hard disk, because that then cannibalizes the amount of processing power that SQL Server has, and everybody starts to slow down. So SQL Server is kind of doing a bit of a balancing act here. And keep in mind, this whole scenario is a great solution when one instance is running. But when we have more than one instance running, it can become a problem, and we'll talk about that a little bit later on, probably in a separate video. But now let's talk about how memory management is handled in SQL Server. What's going on is SQL Server is running, and SQL Server queries the system periodically to determine the amount of free memory that's still out there that the operating system has. And if the free memory is low, in other words, if the operating system looks like it's about to start to run low on memory, SQL Server will voluntarily release memory back to the operating system. If the free memory is high, meaning that there's a lot of extra memory sitting out there, SQL may allocate itself, it may take some of that memory, allocate itself more memory if it's under a workload that it determines that more memory could help it process better. Now, again, it only allocates more memory when the workload requires it. So how do we control memory when we need to? Well, there are two memory options available. And I'm actually going to do a separate video on these, but I'll mention them here. They're min serve memory, obviously for minimum server memory, and maximum server memory. And again, when we're running a single instance of SQL Server on a machine, everything's cool. SQL can allocate memory based on looking at the OS and what it has free, but the minute we get into a more than one instance SQL Server installation, we really should be out there managing that memory using these two options, okay? So by understanding how SQL Server is managing memory by default will help you understand how to use these two settings. So join me in managing SQL Server memory, and if you look at that video, I'm going to go a little deeper into min and max server memory to help you understand how to manage more than one instance's memory on a SQL Server box. Now let's take a look at managing SQL Server memory. Now, I've already mentioned this in the video entitled Memory Allocation. There are two memory options available to us in SQL Server, that is min server memory and max server memory. Let's go out to the SQL Server Management Studio and I'll show you where you can see these things. Notice that if I right click on my SQL Server here and go to Properties, there is a memory page out here, and you'll notice right here on the top, Server Memory Options. Now there's the min server, or the minimum server memory in megabytes, and the maximum server memory in megabytes. All right? These two can be used. For example, if this particular server, this is at the server level, I can determine how much memory gets applied here. Now, if I had another instance here, I could right-click on that instance and do the same thing, and thereby control the memory on each one of my instances. Okay? Now, let's talk about the minimum server memory here first. The default setting, as you saw, was 0. Now, I can use this to guarantee a minimum amount of memory that's always available to that particular instance of SQL Server. So again, if I had two instances on my box here, you would see that first one up there. Let me jump back out there to it. You would see VTCSP, then you would see another instance down here. And I could right-click on either instance, go to Properties, and then go to Memory, and I could set the minimum amount of memory that I want to have for that particular instance of SQL Server. Now, SQL Server, you got to be careful though, will not immediately allocate this amount of memory on startup. Okay, so just because you set it doesn't mean it's going to grab it. SQL Server allocates memory to itself based on workload. Once the memory usage reaches the level that you've set as the minimum due to the workload, SQL cannot free that much memory, any more memory below that, back out to the operating system. So if you put the minimum memory out there at, say, 75 megabytes, then it may not hit the 75 megabytes till the database gets busy enough to need that much. And then from that point on, it'll be at 75, and it will never release below 75 back to the operating system again, okay? Then the max server setting, you saw the default there, 2,147,000,000 and some change megabytes. This is the maximum amount of memory that this instance can allocate. Now, obviously, if you've got two instances, we need to divide this up a little bit. You got to be careful here. If you set the maximum server memory too low, it can cause all kind of problems. The biggest one being it can prevent SQL Server from starting. That's not a dead end. You can start it up in administrative modes and stuff. There's some things you can do. I won't go into that now. You can look that up on Microsoft's website. Here's what I want to get to. You have three options to manage memory when you're running multiple instances. Okay, the first one is use that maximum server memory setting to control memory usage. Set a maximum setting for each instance and just make sure that the total of all your maximum instances does not exceed the total physical memory on the machine. You might even want to leave a little headroom in there and have them both total up to maybe 1 or 2 gigs less than the total memory on the machine. Then use minimum server memory to control the memory usage, and you're just going to go the other way. You're going to set the minimum settings for each instance and make sure the total of all the instances is 1 to 2 gigs less than the total physical memory on the machine. So we're saying that for our two instances, they each get a minimum amount of memory, and we can set those. They can be different for each instance based on whatever we think is going to work on our SQL Server. And of course, you can test the results. Now here's some things you need to think about when you start manipulating or managing SQL Server memory. Multiple instances do require manual memory management. Now, let me back up a second. Right here, you say, wait a minute, there's 3 ways to manage memory. And there are. You can use the maximum, the minimum, or you can do nothing. And oddly enough, do nothing is what most administrators do. Okay, so the third option is not an option. If memory is not managed manually, then the first instance that really starts to run and get a good workload gets all the memory. Then later instances run with minimal memory until the first one gives it back, and then the later one gets busy in the right order and goes and gets some memory. Okay, SQL Server does not automatically balance memory across instances. All right, so if you're running multiple instances, you need to get your hands on managing that memory. Keep in mind, though, one other thing, this is kind of the flip side of that. There's always a flip side, right? If only one instance starts, then it is limited by whatever memory settings it has. So if you had 3 or 4 instances on a computer, on a machine, and you took 2 of the instances off and now you only have 1 left, keep in mind your minimum and maximum memory settings are still going to hold for that. You'll have to go clear those out for that thing to truly allocate all the memory it needs. So anyway, managing SQL Server memory is not really complicated. Just know it's out there. Be familiar with it. Watch for questions about this on design on an exam when you have more than one instance of SQL Server on a server.